This slide shows how you can assign values to Pascal array elements one at a time. It is much similar to Java, but it uses a colon and equal sign as the assign operator. In Fortran 2D and multi-dimensional array declaration is much similar. One-dimensional array declaration only difference is we have to specify start and ending indexes for each dimension within separate square brackets. One major advantage of Pascal over other languages is, it allows dynamic memory allocation, therefore it supports efficient memory utilization. When declaring the variable of a dynamic array type, the initial length of the array is 0. The actual length of the array must be set with the standard setLength function, which will allocate the necessary memory to contain the array elements on the heap. The example shows how to declare a dynamic array. When we use dynamic memory allocation, indexing is always zero-based. Note that the length of the array is set in elements, not in bytes of allocated memory, although these may be the same. The amount of memory allocated is the size of the array multiplied by the size of one element in the array. The memory will be disposed of at the exit of the current procedure or function. It is also possible to resize the array. In that case, as much of the elements in the array as will fit in the new size will be kept. The array can be resized to 0, which effectively resets the variable. At all times, trying to access an element of the array with an index that is not in the current length of the array will generate a runtime error. ALGOL, short for Algorithmic Language, is a family of imperative computer programming languages originally developed in the mid-1950s, which greatly influenced many other languages, and became the de facto way algorithms were described in textbooks and academic works for almost the next 30 years. It was designed to avoid some of the perceived problems with Fortran, and eventually gave rise to many other programming languages, including BC, B, Pascal, Simula, C, and many others. ALGOL introduced code blocks, and the begin and end pairs for delimiting them, and it was also the first language implementing nested function definitions with lexical scope. ALGOL 68 supports arrays with any number of dimensions. Array declaration in ALGOL follows the syntax given in the slide. The given example array declaration will create an array of length 96, which has 4 as starting index and 100 as last index. ALGOL arrays can be used with no array bounds also. Here is the array name and ALGOL is the data type which has no mentioning of array size. In ALGOL, array assignment is done like in modern-day programming languages like C and Java. Given example, assign value 8 to the ith index of the array. ALGOL multi-dimensional array declaration is similar to Pascal's. Syntax is as shown here. The example shows creation of two 2D array of 3 rows and 4 columns. The values given in square braces are the starting and ending index of each dimension. ADA is a structured, statically typed, imperative, wide-spectrum, and object-oriented high-level computer programming language, extended from Pascal and other languages. It was originally designed by a team led by Gene Bias of C2 Honeywell Bull under contract to the United States Department of Defense from 1977 to 1983, to supersede the hundreds of programming languages then used by the Department of Defense. ADA arrays are quite powerful, and so there are quite a few syntax variations. The main difference is that there is no mention of the array size. Array consists of one element per each index of the data type. ADA syntax is as shown here, where you not have to specify the type of elements to be stored in the array, but also the type of index you desire to use. This is quite a difference in comparison with other languages, where you only have to specify type of elements stored in the array. Often you don't need an array of all possible values of the index type. In this case you can subtype your index type to the actually needed range. First and last are the upper and lower bound of the range you want to include for the values that can code for the array. This can be used when the range actually needed is not known until runtime, or you need objects of different lengths. If you are using multi-dimensional arrays, you have to specify the index type you want to use for each dimension. Slide shows how it can be done. Continuing from the previous slide, where we created the 2D array, here it is shown how rows are numbered according to the index type we specified in declaration.